Hello students, welcome to EPG Pathshala. I am Sumalay Roy from Department of Physics and Astrophysics, University of Delhi. Today we are going to discuss about the module Origin of Quantum Mechanics Part 2 from paper Quantum Mechanics. In the preceding module, we studied the quantum nature of electromagnetic radiation at a microscopic level. And being aware of the fact that the phenomena of interference, diffraction, and polarization of light can be successfully explained by the wave properties, we reach to an important conclusion about the dual nature of electromagnetic radiation. That is, it has the ability to manifest itself either as a wave or as photons. Parallel to these developments, side by side, there are equally startling discoveries regarding the atomic structure of matter. In this module, we shall review these atoms and show how this laid the foundations of quantum mechanics. In particular, towards the last section, we introduce de Broglie's hypothesis of a dual wave-particle character of matter at the atomic level. This hypothesis was experimentally verified later by Division and Jarman, showing that material particles like electrons possess these wave-like properties, exhibiting interference and diffraction. Rutherford model of the atom. Soon after the discovery of electrons by J.J. Thomson in 1897, the first outlines of the atomic structures of matter became known when an atom was supposed to consist of a number of negatively charged electrons plus a positively charged residue. However, the picture of the atom became clear only when in 1911 Rutherford's analysis of experimental data on the scattering of alpha particles by thin foil of different elements carried out in 1908 by Geiger and Marson arrived at the conclusion that all the positive charge and almost all the mass of the atom is concentrated in a positively charged nucleus of dimension 10 to the power minus 14 meter, which is of the order of 10 to the power minus 14 meter, compared with the dimension of the atom as a whole of 10 to the power minus 10 meter. This immediately suggests a planetary model of the atom, which is with its structure very much similar to that of the solar system, with the electrons orbiting around the nucleus like planets orbiting around the sun. The electrostatic force of attraction between each electron and the nucleus holds the nucleus together. It was soon realized that this picture of the atom presents several difficulties from the point of view of classical theory. In the first place, due to the orbital motion, the electrons would get accelerated and emit radiation continuously. Consequently, the electron, thus losing energy, would spiral inwardly and eventually collapse into the nucleus. This result is contrary to the experiment since the atom is known to be very much stable. Moreover, the frequency of the emitted radiation, which coincides with that of the orbital motion, should continually increase, thereby producing a continuous spectrum, instead of the observed discrete spectral lines. It is thus clear that electromagnetic theory, despite its success in explaining large scale of phenomena, could not apply to the process at atomic scale. Sommerfeld's generalization of quantum rules, besides the remarkable success achieved by Bohr model, it was felt that the quantization conditions of the orbital angular momentum employed in the derivation was valid only in the case of circular orbits and could not be used in more complicated cases. Soon, it was noticed that above condition is in fact a special case of the condition. Here Q refers to a generalized coordinates and P is the corresponding canonically conjugate momentum. So, limitations of Bohr-Sommerfeld model. It was felt from the beginning that old quantum theory of Bohr and Sommerfeld is, in fact, a strange mixture of incorporating two diagonally opposite views. At one hand, it invokes quantum mechanical concepts. At the same time, it uses methods of classical mechanics. It is not, therefore, not really a fundamental theory. While the postulates on which this theory is based do provide a basis for understanding the stability of the atoms and the observed feature of atomic spectra, the question which remains unanswered is why certain orbits should be completely stable and others not allowed to exist. In this module, we have learned that the experimental status on the emission of discrete spectral lines from hydrogen atom, the Rutherford model of the atom, Bohr's model of hydrogen atom, and study the derivation for the expression of the energy levels, the Stern-Gallac experiment, which gives the experimental support for the prediction of Bohr model of hydrogen atom, Sommerfeld's generalization of quantum rules given by Bohr, and also learned its salient features, and finally, the limitations of the Bohr-Sommerfeld model space quantization using Stern-Gallac experiment, de Broglie's hypothesis, and its experimental verification. Thank you.